A system architecture model has many different types of artifacts and relations. To get the best out of a model and creating it right, something is always required. And I'm pretty sure you already know where I'm going with this. Of course, it's the MBSE methods. Let's get into it. An MBSE method is a method that describes how to create a system architecture model. So that's very important, the how to create it. It describes which artifacts are required to model a system and how they are related to each other. So an MBSE method always supports you and gives you a certain guideline for developing your system architecture by transferring the problems into hopefully well-working solutions. Since there are many artifacts and relations, or in general a lot of information, MBSE methods help by managing the complexity of your project. And also, when the model is created, MBSE methods give you an idea of how to use the model for further development activities. On the market, there are some MBSE methods available already, so you don't have to start from scratch. On this slide, I just want to show you almost all methods or most recognized which are on the market so that you have an idea what methods are out there. And we're going to start with the methods which are recognized by INCOSE. First, of course, it's the INCOSE OSEM method, the Object-Oriented Systems Engineering method by INCOSE itself. Then we have SysMod, that might mean something to some of you. The Systems Modeling Process by Wilkins, also very famous. Then the Cyber Magic Grid by Dassault Systems, and Arcadia, the Architecture Analysis and Design Integrated Approach by Polarisys. Then there is OPM, a little smaller approach, the Object Process Methodology by Dovdori, and the Harmony SE by IBM, Strata, a MBSE method by Wittech Corporation. Then we have the JPL, so the State Analysis Methodology by JPL. The ISE and PPOOA, the Integrated Systems Engineering and Process Pipelines in Object-Oriented Architectures Methodology by Fernandez. So very complicated name, so you do not have to remember the name itself, but just that it's out there. Then the PBSE, so the Pattern-Based Systems Engineering by INCOSE, and many more which are recognized by INCOSE. But other non-recognized architecting methods, but which can be associated to MBSE, but which are not directly recognized by INCOSE out there as well, and I want to give you an idea of some of them now. So we have first here the FAS, so the Functional Architecture for Systems method by YESCO. The FAS4M, so the Functional Architectures of Systems for Mechanical Engineers. The CONSENS, so the Conceptual Design Specification Technique for the Engineering of Complex Systems. The C and C squared A, the Contact and Channel Approach by Albers. The FBS, Function Behavior Structure by Gero, and many, many more. So this is, of course, nothing you have to remember in detail, but to just give you an idea that there are many methods out there, and if you maybe hear a name here or there, again, you can order that into the MBSE method folder. Okay, so let's continue. Let's consider some MBSE methods and compare them by starting with the creator and the industrial sectors. There is the previously mentioned OSEM method, which was developed by Lockheed Martin and later adopted by INCOSE in the 1990s. The method was developed in the USA and primarily for the military industry and mainly for control software there. Today, OSEM is open for all industrial sectors. Then we have SysMod, which was developed by Tim Wilkins and Richard M. Soley, somewhere in around, I think, 2005 in Germany and in the USA. The method is used for system development and software development. In 2010, the SAW bought the MBSE method called Magic Grid. A Magic Grid is a result of best practices and a lot of industrial feedback. Magic Grid is regularly updated and was developed in Lithuania. The main industry sectors are transportation and defense. Then we have the Arcadia method, and Arcadia was developed back in the early 2000s by Thales and was very mainly pushed by the aerospace and defense industry as well. In 2015, Arcadia and its application in the modeling tool was released to the whole public. Since the feelings of using methods based on UML and the first versions of SysML were mixed, they decided to develop a kind of own MBSE method that meets the needs of systems engineering. And OPM. OPM is an alternative to the other methods and has one main focus: just to be simple. To do so, OPM dramatically reduced the number of modeling elements. It has, of course, its pros, but also its cons. Another difference is shown by the field of application of the MBSE method. OSAM is a SysML-based MBSE method and partly also uses UML. UML elements and diagrams are used when there is no appropriate SysML element or diagram available. OSAM is tool independent and can be applied fully in every tool that supports SysML. SysMod is also another SysML-based MBSE method, also, as we said before, tool independent. SysMod requires to extend SysML with some stereotypes. This can be done with a profiling mechanism of SysML and is in general often done like the tailoring to the specific needs. There are also plugins available that include already the SysML extensions. Magic Grid is also a SysML-based MBSE method. Magic Grid is in principle tool-dependent but works best in the Cameo system modeler from the SAW. And then Arcadia is based on the Capella language, a domain-specific modeling language. Arcadia is strongly linked to the Capella language and is only used in the Capella tool. The Capella in general is open source. And then OPM, which has its own language and diagrams and is less comparable to SysML or Capella. OPM in general is not tool independent and only runs on OP Cloud or OPCAT. Each of the MBSE methods contain a set of activities that are executed. These activities are not the same, but pretty similar patterns, if you compare to RFLP, can be recognized. Before OSAM really starts, the model is set up, meaning to create structures to organize all the artifacts. With that done, the stakeholder needs are analyzed and requirements are derived from that. Logical architecture is the solution based on the requirements, which can lead to different physical architectures. In parallel, the system is evaluated with analysis methods and is optimized. Another activity here is to create all the traces back to the requirements. SysMod starts with documenting the system idea and objectives and derives a base architecture from that. Only afterwards requirements are determined. Done so, the system context is analyzed in detail and use cases, which are very important, are modeled. This is the base for creating the logical and later on the physical architecture as a solution. Magic Grid starts in the problem domain with modeling the stakeholder needs, the system context, and some use cases. Principal subsystems are defined and functional analysis is performed to understand the problem in detail. So that's what they focus on here. Requirements are the first activity in the solution domain, followed by behavioral and structural description. Measurements of effectiveness indicators are defined to analyze the system. Arcadia starts with the operational analysis to get an understanding of how users and stakeholders operate in the considered area. That's a little different approach. So based on that, a system analysis is performed, put a system into place that meets the operational needs. Following, a logical architecture is derived from the result of the system analysis and later transferred to the physical architecture. The product strategy activity considers the later steps in the development process, such as implementation, integration, verification, and validation. An OPM, last but not least, defines the scope and purpose of the model at the beginning. With the objects, so O and the processes P, defined, a visualization of them on several diagrams can be done. They are enriched with additional information such as attributes, for example. And later, the model is verified and used in the development process. When analyzing the shown MBSE methods, so you have seen a lot of them now, the RFLP pattern as a fundamental principle is in the center. Most of the methods are focusing on new innovative products, so from the idea to the solution. The methods have a needs or problem domain to understand the customer and operation, and also then on the opposite side, a solution domain. The result of when an MBSE method is applied is always the system architecture model. MBSE methods provide the possibility to model the entire mechatronic or cyber-physical system without discipline-specific details. Okay, so this module, I know it was a lot and many different methods, but it should give you an overview. So when we dive deeper into the different methods in the next modules, that you have already an idea how they are connected and what is the difference between them.